This is Higher Maths, it's practice paper E. We're looking at the calculator paper and it's question number 2. The rectangular based pyramid has vertices 6, 0, 0, 6, 8, 0 and 3, 4, 7. Okay? Write down the coordinates of C. So all I need to do is look at the diagram and pick out the parts that I need to know. So I know that that's going to be a square base on the bottom. I know that that's 0. Okay, so the x coordinate must be 0, so it's not moved along at all. So let's go for writing down the values that I'm going to put in here. So 0. Okay, it's gone back the way in the y direction, and it's gone back the same amount as b has gone back, so it's going to be that 8 that I'm going to pick from there for the y coordinate, and there's no height to it, it's sitting on the axis, so for the z direction there's a 0 there as well. So 0, 8, 0 for the coordinates of the C. Right, so let's go ahead, express AC and AD vectors in component form. Okay, so let's go for part 2. So we're going for AC first of all, and that's going to be equal to C minus A, position vectors. Right, let's work these out. So C, we've already got there is 0, 8, 0, that's the one that we just worked out. What we've got is, we've got A as 6, 0, 0, just from above. Okay, that should give me minus 6, 8 and 0. So that's the components of AC. AD, just something similar. What I'll do is just set these up. I know that A is the same that's going to be there, so I'll just put that in straight away. And I'm looking for D now. So D is from up above, 3, 4, 7. And just subtracting them away, so that'd be minus 3 at the top, we've got 4 in the middle and 7 there at the bottom for the Z component. Okay, so there's the components there complete. We're on to part B. Calculate the size of the angle ACAD. Right then, so CAD would be the angle that would come from this far corner, okay, this far corner here of the square-based pyramid, and from there to there, and it's going to go up here to there. Okay, so that's what we're looking at there. We're really interested in that angle in there. Okay, right, so let's go ahead and look at a formula for this one. And remember, when we're trying to work out an angle, we need to understand what the component vectors are that are going away from it. And kind of luckily enough here, we've been given the clues to work out these here. So it's A to C. Okay, so what we're working out first of all is the size of the angle CAD, and I can look at the formula sheet that will help me out a bit to try and get this formula together. And what we'll do is I'll find the cosine of CAD, and I know it's going to be both vectors, so written down, and what we're going to do is we're going to find the dot product between them. So what I've got is I've got AC dot AD, and then that's all going to be divided by the magnitude of AC and the magnitude of AD multiplied together. Right, so let's go ahead and work these out. So I've got the components here for these vectors, and all I'm going to do is I'm just going to put them into this form. I'm just going to keep it all together. You may have been taught to separate them out and then gather them up at the end, but either way it's still going to work out okay. So what we've got here is, doing the scalar product or the dot product, it's going to be minus 6 times the minus 3. I'm going to add to that 8 times 4, and I'm going to add to that 0 times 7. So that's my top line there. On the bottom there, I'm going to be working out the magnitudes. Okay, so the magnitude is the square root of each of the components squared. Okay, so I've got minus 6 squared. I'm going to add to that 8 squared plus 0 squared. The AD, the magnitude of the AD, minus 3 squared plus 4 squared plus 7 squared. Okay, and what that should work out to be, so that will be, let's see, that's going to be 18 plus 32, so that's going to give me 50 on the top. On the bottom what I've got is, I've got the root of 100, I'll just write it like that just now, and what I've got here is I've got 9, 16 and 49. Just add them together should give me 74, so that will be the root 74. Right, so what I can do here is I can just rewrite that over here, and what we've got is I'll just write that as 50. That's going to be 10 on the bottom there, and that's going to be times root 74, or even simplified down even further would be 5 all over root 74. So what we've got there is cosine CAD is going to be equal to 5 over root 74. Right, so all I'll do is I'll put that in the calculator to work out the angle. So CAD is going to be equal to the inverse cosine of 5 over root 74, and from there I should be able to get my answer, and that will work out to be 54.4623 or 54.5 degrees to 1 decimal place, and that would be the question complete. Right, let's have a look at marking for this one. So for part A we've got 3 marks. We've got 3 things that we did there. So there we go, 1 mark for that, 1 mark for the vector AC, and for AD in component form. So there's the first 3 marks. 5 marks for the next part. What I'm going to give is 1 mark for setting up the equation correctly. I'll go for 1 mark for getting the dot product correct, 1 mark for getting the magnitude of AC, and 1 mark there for getting the magnitude of AD. So that's 4 marks, 1 more to be given, and there's our final answer. Okay, so out of 8 marks, this question here.